All right, guys, our first property, our first theorem of the day, the square root of a negative number property. If r is a positive real number, then when we take the square root of negative r, we get I square root of r. That's pretty much what we were talking about the last few days. When we take the square root of a negative, the negative comes out as I, and then we would reduce the radical r. By the first property, it follows that if we square I squared of r, we'll get back to negative r. It'll go back to what it was. So if we take square root of negative, the negative is going to come out as I, and we have the square root of r. If we take this and square it, we're just going to get back to negative r, what we started with. Now, up to this point, we've solved different quadratic equations. We've solved quadratic equations, but all of our equations had some type of root to it, or we haven't solved any with I. And that's what we're going to be looking at today. Now, there's only one method that we have so far that would solve for I, where we can get I, or a non-integer rational solution, and that's our square root method. So when we look at this first problem here, x squared plus 4 is equal to 0. We could try graphing this to solve this here. So we can go y equals x squared plus 4 and hit graph. And well, when we graph, we're looking for where the graph crosses the x-axis. And here, it does not cross the x-axis at any point. So this, according to graphing, would be no real solutions. But that's fine, because there is a way for us to find the solutions. And we can do that by taking the square root method. Now, the reason we can use the square root method on this here is there is no middle term. There is no term with x to the first power. So the first thing we need to do is get the x squared term by itself. And the first thing we can do to do that is to subtract 4 from both sides, because our 4 minus 4 would be 0, telling us that x squared is equal to negative 4. At this point here, we can take the square root of both sides to get x by itself, because the square root of x squared is x is equal to plus or minus, because whenever we take square root of both sides, we have to add the plus or minus. Now we need to simplify the square root of negative 4. Well, with this here, the negative inside the radical is going to come out as I. And since we simplified the negative inside the radical, what we're left with is the square root of 4. And well, our square root of 4 is 2. So the square root of negative 4 is 2i. And so what that tells us is that the solution for this here, the value of x that will make this be 0, is either positive or negative 2i. Questions on this here? Now we could plug this into the graphing calculator to check our answer. And we can say parentheses 2i close parentheses squared plus 4. And it tells us that is indeed 0. We can also do the same thing with negative 2i plus 4. And check that here. And it is also 0. So 2i and negative 2i are our two solutions. Questions on this here? Okay. We're going to look at the next one. 2x squared minus 11 equals negative 47. Again, we're going to be using the square root method, and part of the reason we know we can use the square root method is there is no middle term. There's no x to the first power, just x. We just have x squared. So the first thing we need to do is get the x squared term by itself. And our first step in getting the x squared term by itself is 2. Add 11 to both sides. And after we add 11 to both sides, our negative 11 plus 11 would be 0, leaving us with 2x squared on the left-hand side. Negative 47 plus 11 is negative 36. Looking at this here is the x squared term by itself. No, so what do we need to do next? We need to divide both sides by 2. 2x squared divided by 2 is going to be x squared. Negative 36 divided by 2 is going to be negative 18. Now the x squared term is indeed by itself, so we can take the square root of both sides. On the left-hand side, our square root and square will simplify out, leaving us with x is equal to plus or minus. We have to put the plus or minus whenever we take the square root of both sides. Now we need to take the square root of negative 18. Well, the negative part of this square root is going to come out as I. Questions on this so far? Because again, we can take this negative out as I, and what that leaves us with is the square root of 18. Now the 30xs, our yellow calculator, will simplify the square root of 18, and it tells us that it is 3 square roots of 2. So that tells us that the square root of 18 is 3 square roots of 2. So the square root of negative 18 would be 3i square roots of 2. So we simplify the negative inside the radical first. We bring it out as I. Then we simplify the rest of the radical. And that's it. Questions on this here? Questions on anything we've done so far? Let's look at the next step, or next one. Our next problem, find the zeros of f of x equals 4x squared plus 20. Again, when we're finding the zeros, we're trying to find what value of x that's going to make 4x squared plus 20 be what? 0. We're trying to find the zeros. We're trying to find out what value of x will make this function be 0. And again, we can graph it, but again, just like the previous one, equals 4x squared plus 20. It doesn't cross the x-axis. There is no point where this function is going to intersect the x-axis. So, do we have a middle term? Do we have an x to the first power, just x? No, we just have x squared. So we can use the square root method. First thing we can do with the square root method is to subtract 20 from both sides, because our 20 minus 20 is 0, leaving us with 4x squared is equal to negative 20. Our next step would be to divide both sides by 4. 4x squared divided by 4 is going to be x squared is equal to negative 20 divided by 4 is negative 5. Is our x squared term by itself? Yes. So that means we can take the square root of both sides. And our square root and square would cancel, telling us that x is equal to plus or minus. Now we need to simplify the square root of -5. Well, for us here, again, the negative is going to come out as I, leaving us with the square root of 5. So we just need to see, can we take the square root of 5? Can we simplify that down any further? Second square root of 5 is, well, the square root of 5. Questions on this here? Questions on anything we've done so far? All right. As we've seen up to this point, square root method works well on some. Factoring works well on some. Graphing works well on some. And we don't have a method that works for all of them. And that's really what we're going to start looking at today, is a method that will work for any and all quadratics. Now we want to solve this here, x squared minus 16x plus 64 equals 100, using square roots, using the square root method. Now normally we would get this equal to 0 and try to get it equal to 0, but for this one here, we're going to do something a little bit different. I want to factor this here first. I want to factor the x squared minus 16x plus 64. Now, between the x squared, 16x, and 64, there is no greatest common factor. That's fine. We can move on to our signs. Since the third term is positive, the signs are the same, and they match the sign of the middle term, which is negative. So our signs are negative and negative. Now we need to find the factors of the first and third term. Well, our first term is x squared. So we'd have x and x. Now our factors of 64 are 1 and 64, 2 and 32. 3 is not a factor, but 4 and 16. 5 is not a factor, 6 is not a factor. 7 isn't a factor, but then we have 8 and 8. Well, let's try 8 and 8. And if we're to check this here, 8 times, or negative 8 times x is negative 8x. Negative 8 times x is negative 8x. Which does give us the negative 16x middle term that we wanted. Questions on what we've done so far, or how we got this factored? Okay. Now at this point here, we can't use the zero product property because, well, it's not equal to 0. Now we do have two things multiplied together that give us 100. Well, one of them could be 1, the other could be 100. One of them could be 2, the other could be 50. We have many different possible ways, almost an infinite number of possible ways to multiply two things together and get 100. But what do you notice about those two factors? They're the same, yes? So what we could actually do is rewrite this as 8x minus 8 squared. Because what x squared minus 16x plus 64 is, this has a special name. We call this a perfect square trinomial. It is a quadratic that can be rewritten as a single set of parentheses squared. And the reason that this is important, the reason this is nice is, well, I can use the square root method on this. Because if I can rewrite that quadratic as a single set of parentheses being squared, we can use x minus 8 squared, yes, because x minus 8 times x minus 8 is the same as x minus 8 squared, yes. And if we take the square root of it, well, the square root, then it would indeed be x minus 8 is equal to plus or minus square root of 100, which is 10. So essentially, if we can get the equations to be a perfect square trinomial, we can get our x squared, our x, and our constant term to such a form that we could rewrite as a set of parentheses squared. We could take the square root of both sides and then solve every single time. Well, at this point here, we need to just solve. And to get x by itself, we would add 8, because our negative 8 plus 8 would be 0, leaving x by itself. Whenever we add or subtract something from both sides, we do put it in front of the plus or minus, getting this to this point here. Questions on this so far? Questions on anything we've done so far? Can I add 8 and 10? Can we do 8 plus 10? Yeah. Can we do 8 minus 10? Yes, because here really this is saying that we have 8 plus 10 and x is equal to 8 minus 10. Now, if we're not able to add or subtract these, if the 10 had a radical or I, we aren't able to actually combine like terms, we leave it with the plus or minus. But here, our 8 plus 10 is 18. Our 8 minus 10 is negative 2, because if we can reduce it, we need to reduce it. If that term, when we take that square root, if what comes out of it still has a radical or has I, or has both a radical and I, we leave it with the plus or minus. But here, if we're able to add and subtract these two numbers, we need to add and subtract. Questions on this here? So the reason that this is nice and the reason this works well is because of the fact that we could rewrite this quadratic, factor it down to a single set of parentheses squared. Because when we can rewrite it as a single set of parentheses squared, it doesn't matter what's on the other side. It doesn't matter if what's on the other side is positive, negative, a perfect square. We can still take the square root of both sides and solve and get our answer. Questions on this here? This first method that works every single time is called completing the square, because we're trying to make that quadratic a perfect square trinomial. We're trying to make it into a square. Now, the first key step in this is to find the value of c that will make the quadratic into a perfect square trinomial. And incidentally, we do have a theorem for this here. This value of c that we need is equal to b over 2 squared. C is equal to b over 2 squared. Because this right here, being able to make this perfect square trinomial, is the linchpin in this whole setup, in this whole process of solving by completing the square. Now, our b, c, all of this comes from the general form of our ax squared plus bx plus c. And comparing to the general form, what's the value of a? Well, a is actually the number in front of x squared. So it would be 1. B would be 14. And well, we don't know what c is yet. We still need to find it. To find the value of c that we need to make this be a perfect square trinomial, so that it factors down to a single set of parentheses squared, well, we have to plug b into this formula here to find the value of c that works. So c is equal to b over 2 squared. And what's our value of b? 14. So here we're saying we're taking 14 and dividing it by 2 and then squaring it. And yes, at this point we could type this whole thing in the calculator, let it do it for us. But I highly suggest, I highly recommend, let's just do the division of 2 first. Here, 14 divided by 2 is 7. Now we can square it. 7 squared is 49. So our value of c in this case is 49. Questions on how we found the value of c? So our perfect square trinomial is going to be x squared plus 14x plus 49. Now the last thing we need to do is rewrite this as a single set of parentheses being squared. Our perfect square trinomial, we need to factor it. And whenever we factor these perfect square trinomials, especially as a part of completing the square, we can write our parentheses squared, and x is going to be by itself. There's not going to be a number in front of it. Now, all we're missing at this point is the sign and the number that go in these parentheses here. And this part, I think, is kind of neat. And the number inside that sign that go inside our parentheses when we factor is the same number and sign of our value of c before we square it. So here, the number inside the parentheses before we squared it to find c was 7, but not just 7, it was positive 7. So that means inside these here, we plug in plus 7, positive 7. That means if the number inside the parentheses before we squared it was negative 7, our factors would have been x minus 7 squared. Does that make sense? Yeah, and that's also why I said it's better to just divide by 2, not type in the 14 divided by 2 squared, type the whole thing in all at once. Because it will give us the 49, but then we're going to have to go back and find this factor that goes in there. But this here is our answer. Questions on this here? And really finding this value of c is what's key for being able to do completing the square. Are you ready for the next one? I'm going to draw lines down here just to split this up because, well, unlike yours, mine's all on the same page. So what we want to do is find the value of c for each one of these here. We get our perfect square trinomial and then factor it. Well, for this first one here, all of these, c is equal to b over 2 squared. And in this first one here, our first a term is 1. Our b term, value b is what? 8, positive 8. And we still need to find c. And when we find c, c is equal to b over 2 squared. And for this here, b over 2 would be 8 over 2 squared. Can we divide 8 by 2? And what is 8 divided by 2? 4. Squared, and 4 squared is 16. So our perfect square trinomial is x squared plus 8x plus 16. That's half our answer. Now we need to factor it. So we'll have our set of parentheses, x, and that parentheses being squared. The number and sign that go inside here is our number and sign inside the parentheses before we squared it to find c. Since it was positive 4 inside that parentheses, we have x plus 4 as our factor. plus 4 squared. Questions on this here? Are you ready for the next one? Let's look at the next one here. So again, for number 5, we need to find the value of c, because once we find c, we'll have our perfect square trinomial, and then we know what we need to do to factor it. Well, again, a is 1. B is what? -2. So we can plug that value of b in to find this value of c. Because again, our c is equal to b over 2 squared. So we have -2 over 2 squared. Well, -2 divided by 2 is -1 squared. And -1 squared, -1 times -1 is indeed 1. So our value of c in this case is 1. Try that again. So our perfect square trinomial would be x squared minus 2x plus 1. Questions on anything we've done so far? So what would go inside the parentheses with our x? -1. Because the number inside our parentheses before we squared it to find c was -1. So the number we put inside our parentheses when factoring is -1, giving us x minus 1 squared. Questions on this here? Now with this here, again, a is 1. B in this time is -9. We don't have the value of c. And that's what we can find, because c, again, is b over 2 squared. Well, our b value in this case is -9. Can we divide -9 by 2 nicely? No. 9 does not divide by -2, or -9 does not divide by 2 nicely. It's odd, it doesn't work. We can divide and get a decimal, but especially when we start using completing the square and solving these by completing the square, it's going to be better to leave it as a fraction than it is to write it as a decimal. Because again, with completing the square, what we've done already, we're going to have to take the square root at some point. It's easier to take the square root of a fraction than it is to take the square root of a decimal. So we're going to leave it. And we can square it at this point. And -9/2 squared is going to be 81/4, telling us that our perfect square trinomial is x squared minus 9x plus 81/4. And again, the number that goes in here with x is whatever the number is before we squared it. So we'd have x minus 9/2 squared. Questions on any of this here so far? Yes, sir. Yes. Questions on anything we've done so far? Yes. Right, because if we're looking at factoring, our main step for finding the sign with factoring, and the question is about the sign that goes inside this parentheses, well, if I were looking to factor this, I'd look at the third term. If the third term is positive, the signs are the same and match the sign of the middle term. Here, the middle term is what? Negative, so both signs would be negative. It's going to condense to 1, so it is negative. Does that make sense? Right, and it does work out nicely that number and sign inside here before we square it's going to work out that way every single time. So we don't have to worry so much about signs because of this case or this case. It's always going to work out this way here. And the C value is always going to be positive because we're squaring it. Because whenever we square a number, multiply it by itself, it's going to be positive. That's also why we had such issues with taking the square root of a negative number, because there's no way to take the square root of a negative and get a real number. So, questions on this here? All right, so you're going to turn the page over, and I would go about halfway down that page, because these here are the 4 steps for completing the square. I would have these written down, because you're going to need these here at some point, because we are going to be doing more with completing the square in this chapter here. Our first step is A equal to 1. If not, make it so. Our second step is to get all the constant terms away from the variables. We want the constant terms on one side, variables on the other. Our third step is to find the value of C, which is equal to B over 2 squared. We want to plug it in and plug it in. Plug in that value of C in. Once we do that, we move on to our last step, which is to find the perfect square trinomial, which is what we had with C. Really, we're just finding our set of parentheses squared. We're getting it into factored form and solving by using the square root method. Hey everybody, I think we have still a few writing. That's fine. He's not back yet, but be here shortly. All right. So we're going to look at the first one on the top of that page, our x squared. I'm going to have to look at it here in a second. our x squared minus 10x plus 7 equals 0. We're going to solve this by completing the square. Now I'm going to rewrite it down below so that we have a little bit of space. Y'all don't have to because you don't have the extra wording next to it. Now, our first step was what? Is a equal to 1? Is the number in front of x squared 1? Yes, because if it wasn't, we'd have to make it be 1. Make it be so. Okay, step 1's done. Step 2, get the constant terms by themselves. We want the constant terms, the numbers on one side, variables on the other, and leave 2 spaces. So what we can do here is move the 7. I need to move the 7. And since the 7 is positive, I'm going to subtract it from both sides. So on the left-hand side, we'll have x squared minus 10x plus blank equals negative 7 plus blank. We're going to leave 2 spaces. And again, the reason we're leaving 2 spaces is we're going to have to plug back in the value of c to make this a perfect square trinomial. I need to make the left-hand side be a perfect square trinomial so I can rewrite it as a single set of parentheses being squared. Questions on steps 1 or 2? We feel good with steps 1 and 2. Step number 3 is to find the value of c. And c is equal to b over 2 squared. Our value b in this case is what? Negative 10. And again, it's not wrong to go on and plug it in as negative 10 over 2 inside parentheses squared to get our answer, but it's good to divide it first because negative 10 divided by 2 is negative 5. It's telling me what's going to go inside that parentheses when we factor. Now negative 5 squared, negative 5 times negative 5 is 25. So our perfect square trinomial would be x squared minus 10x plus 25. Questions on how we got to this here? Well, if I add something to one side, we have to add it to the other. I can't just add one thing to one side. Okay. That's why we have the 2 spaces, so we can put it in both sides and still have the equation be the same. We're not changing anything, just changing how it looks. Our next step is to factor the x squared minus 10x plus 25 into a single set of parentheses being squared. So we'll have our parentheses, we'll have x. The number and sign of what goes inside this parentheses is the same as the number and sign of what's inside our parentheses before we square it. So this here would be negative 5. So it's telling us that x squared minus 10x plus 25 factors to x minus 5 squared. Questions on this so far? Negative 7 plus 25 is 18. Now we can solve. And our first step in solving at this point here is going to be to take the square root of both sides. Because on the left-hand side, the square root and square would cancel, telling me that x minus 5 is equal to plus or minus the square root of 18. Well, it's not negative, so we can go on and just grab the calculator. Second square root of 18 is 3 square root of 2. And last but not least, we need to find the value of x. We need to get x by itself. So the last thing we can do here is add 5 to both sides, because our negative 5 plus 5 would be 0. And since we added something to both sides, we do put it in front of our plus or minus, telling us that x is equal to 5 plus or minus 3 square roots of 2. Questions on how we got to this point here? Can we add 5 and 3 square root of 2 together? Are they like terms? No. And if we wanted to make sure, I can grab the 30xs and do 5 plus 3 square root of 2. Helps if I actually type a number in there. It's just 5 plus 3 square root of 2. It flipped it, but that is the same thing. Since we can't combine them without turning the radical into a decimal, there's our final answer. If we could simplify it, we need to simplify it. If we can't, we're not going to. Questions on this here? On. 3 through 5, 11 through 18. 3 and 5 are kind of like the first one we did, our set of parentheses squared. If you do have questions on it, please ask. Our 11 through 18 is finding that value of c to get our perfect square trinomial and then factoring it. That's all we're going to do today.